Dear friends, welcome to Bond with Electrochemistry YouTube channel. In this video, I am going to explain the previous year questions which are appeared in University of Hyderabad PG Entrance Examination in Chemistry from the lesson Nuclear Chemistry from the year 2010 to 2015. These are year-wise questions which are appeared in University of Hyderabad PG Entrance Examination from the lesson of Nuclear Chemistry. N14 upon bombardment with a neutron gives 14C plus X. In another reaction, 14N upon bombardment with an alpha particle gives 17 oxygen plus Y. X and Y are. Okay, these are nuclear reactions. The first reaction is N. This one is atomic number is 7. Mass is 14. So when you bombard with the neutron, the atomic number is 0, 0 and 1. So when you balance this equation, there is a formation of C14 and the atomic number is 6. When you balance this one, you get 7 plus 0, so 7. Here is 6, so the atomic number will be 1. 14 plus 150, so this one will be 1. So atomic number is 1, atomic mass is 1. So the particle is 1H1. This one is a proton. The particle is proton. Let's take the second nuclear reaction, that is 14N, 714. Upon bombardment with an alpha particle, this is the alpha particle, dipositive helium nucleus, to He4. So when you balance 7 plus 2, this one is 9, but here there is a formation of oxygen 8 and this one is 17. When you balance this equation, you will get 7 plus 2, 9. So 8 plus 1 will be 9. And 14 plus 4, 18. 17 plus 1 is 18. So again, you are getting proton. So X is proton and also Y also proton. So what is the correct option? Both are protons. Given that 18 fluorine undergoes 90% radioactive decay in 366 minutes, the half-life T off for 18F is. We know that radioactive decay it follows first order kinetics. First order kinetics. If you take any radioactive decay, the kinetics of radioactive decay is first order kinetics. We know the integral equation of first order kinetics, that is K is equal to K is equal to 1 by T or 2.303 by T log A by A minus X. A is the initial amount, A minus X is the final amount. Here, radioactive decay, it takes place in 366 minutes. T is given 366 minutes and undergoes 90% of radioactive decay. Initial, let's take 100. 90% of radioactive decay means X is 90%. So 90% of radioactive decay means X is 90. So A minus X is equal to 10. If you take the 100 nuclei, 90 nuclei will be participated in the radioactive decay and there is a remaining of 10 nuclei. So by this equation we can calculate 2.303 by T log the initial number of nuclei 100, let's take 90 consumed, so 10 will be equal to 2.303 by T value is given, it's 366. We have to calculate half-life time. We know the relation between half-life time and rate constant. This is a relation T of is equal to 0.693 by K or lambda. So 0.693, here the K value 2.303 by 366. So it will be into 366. After final calculation, you will get T of is equal to 110 minutes. The radiation intensity of a sample of radioactive sodium, half-life time is given, will become 1/10 of its original intensity in. Here T off is given. T off is given. It's a 15 hours. We can calculate lambda or K value, rate constant of radioactive decay. That is 0.693 by 50. K is equal to 0.693 by T off. This is the relation. Then we have to calculate the radiation intensity of a sample of radioactive will become 1/10 of its original intensity in what time? Uh, what is the time? Okay, we have to calculate T. T is equal to 2.303 by K log A by A minus X. Here, initially, let's take A is equal to 1/10 of its original intensity. Let's take original intensity is 100, and 1/10 means A minus X will become 100 by 10. So it will be 10. So when you substitute this equation 2.303 by K value, it will be 0.693 into 15 log. Okay, the radiation intensity of a sample of radioactive will become 1/10 of its original intensity. Initial, how many sodiums are there? 100. It becomes 10. 1 by 10 means it becomes 10. So it will be 10 log 10. Log 10 is 1. So you will get 2.303 into 15 divided by 0.693. Log 10 is 1 into 1. So after simplification, you will get 15 hours. So C is the correct option. What is the decay constant? In first order kinetics, decay constant means it's a rate constant for a radioactive isotope which decreases to 34% of its original mass in 2.48 hours. So what is the decay constant? We have to calculate lambda or K. K is equal to, we know the equation 2.303 by T log initial concentration by final concentration, or initial number of nuclei by final number of nuclei. So what are the parameters which are given? T is given, and initial, let's take A as 100, and it decreases to 34% of its original mass. That means it decreases to, not decreases by. So A minus X is 34. Suppose decreases by means the value is X, but decreases to means A minus X is given. A minus X is equal to 34. So 2.303 by T, which is 2.48 log. A value is 100. So it decreases to 34. So after simplification, you will get around 0.435 our inverse. The product when the isotope thorium-9234 undergoes a series of 2 beta emissions followed by 2 alpha emissions is. So we know the beta emission, it's nothing but beta minus 1 is a 0 or minus 1 E0. So this is a beta emission, and the 2 alpha emissions, it's a 2He4. Let's take the nuclear reaction. Thorium 90, 234. It emits, there is an emission of 2 beta particles, 2 beta minus 1, 0. So we have to balance this equation. Left side we have atomic number 90. Here we have minus 2. Minus 2. So it should be 92. And let's take mass. Left side we have 234. Right side we have 0. So we have to balance this one. It will be 234. 92 atomic number is a uranium. 92, 234. Let's check. This one is 90. 92 minus 2, it will be 90. 234, 234 plus 0, 234. There is a balancing of nuclear reaction. A second thing, 2 emissions followed by 2 alpha emissions. Let's take this one, uranium 92, 234, 2 alpha emissions, 2H24. Let's take atomic number, 2 into 2, 4. So here already we have 4. So we have to subtract 4. 92 minus 4, it will be equal to 92 minus 4, it will be equal to 88. So it will be 88. And here we have 234. Here we have 8. 2 into 4, 8. 234 minus 8, it will be 6. And 226. So 226. Atomic number 88. It's a alkali metal, alkali radioactive element, that is radium. Radium 88, 226. So finally this nuclide will be formed after emission of 2 beta emissions and 2 alpha emissions. So this is the correct option. The second nuclide formed in the following fission reaction is, it's a fission reaction. We have to balance atomic mass and atomic number. This is atomic number. On left side we have atomic number 92 plus 0 is 92. Right side we have 42 plus 2 into 0, 0. So we have to add 50. When this one is 50, there is a balancing of atomic number. So this one is 50. Let's take 50. We know the element 50 is tin. So next atomic mass 235 plus 1 is 236. Right side we have 103 plus 2, 105. So when you balance atomic mass, so 105, you will get 131. So what is the correct option? Tin 50, 131. D is the correct option.